Welcome viewers. In this video we will see the series opposition of a coupled circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic series opposition. Consider the circuit. Two inductors are connected in series. The voltage, applied voltage is V of t. The current flowing is I1. So this is the equivalent circuit. With the two inductors are connected in series, the equivalent inductance we can write it as LB. Now we'll see the dotted. So because of series connection, the same current is flowing through L1 and L2. This M is the mutual inductance between L1 and L2. See, the current enters at the dotted end for the inductor L1. Similarly, the current leaves at the dotted end for L2. So that it is called a series opposition. Suppose the dot is available here, both the L1 and L2, the current enters at the dotted end means there is series added. Both the inductor will be added together. But here the current enters L1 at dotted end, leaves L2 at dotted end. So that both are opposing together. This M is opposing together. So based on that, by applying the Kirchhoff's voltage law, we can write the equation. So the Kirchhoff voltage law is the voltage, applied voltage equal to drop across L1 and L2 as well as M. So that by using that V of t, applied voltage equal to drop. Resist the inductive drop across L1 is L1 di by dt. Similarly, the mutual inductance due to L1, M di by dt. Because of opposition, we are having negative sign. Similarly, the drop across L2 di by dt. Mutual inductance due to L2 is M di by dt, that is opposing. Due to opposing, it is minus. That is equal to V of t. So this is the drop across L1, drop due to drop of the mutual inductance due to L1. Voltage drop across L2, inductor L2. This is mutual inductance drop due to L2. So the di by dt available commonly. So we can write it as L1 minus M plus L2 minus M equal to V of t. So that can be written as L1 plus L2 minus 2M. The negative available di by dt. So the same thing we can write this equation also, equivalent circuit. V of t equal to LB di by dt. Right. So same equation we can apply for the second circuit. So that LA di by dt equal to V of t. Let L be the equivalent inductance of the combination. So by comparing these two equations, this LA is nothing but L1 plus L2 minus 2M. LB equal to L1 plus L2 minus 2M. So if it is seriously adding means L1 plus L2 plus 2M, while opposing we got the equivalent inductances L1 plus L2 minus 2M. So in this video we discuss the equivalent circuit as of a series opposing circuit. Two inductors are connected, while it is opposing, the equivalent inductance is L1 plus L2 minus 2M. The current enters at the dot of the both the inductor means series adding L1 plus L2 plus 2M. If the current enters at one inductor and leaves and another inductor at the dotted means it is series opposition. In that case, the equivalent inductance is L1 plus L2 minus 2M. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.